All right, hello people watching this video. This is 7-1. We are, circle these words please on your paper, everybody, multiplying and dividing rational expressions today. Multiplying and dividing rational expressions, okay? I'm going to give you an example, a really easy example of multiplying and dividing rational expressions. Let's say that we have 2/3 and we are multiplying that by 1/6, okay? Now, this is an example. I'm just making this up. Eventually, later on, we're going to be doing this with x's involved. So it does get a little bit harder than this. But my question is, 7-1 is multiplying and dividing, okay? Section 7-2, let me just scroll for you to section 7-2, which is adding and subtracting. I thought when we learned like math, like in first grade or kindergarten maybe even, we learned to add and subtract before we multiply. Like, why are we doing it the reverse way? Like, multiplying and dividing should surely be harder than adding and subtracting, but why are we learning that first? No, that's when it's set equal. So, not quite, but you're on the right idea, kind of. Multiplying, dividing. Let's say, here's the deal. Let's say I have that same problem, but now I'm adding instead. Okay? The top one we're multiplying, the bottom one we're adding. Adding and subtracting these rational expressions is actually a lot harder than multiplying and dividing, because when we add these, like if we look at this problem, what do we have to do? We have to find a common denominator, right? Multiplying and dividing, we don't have to find a common denominator, so this is actually easier to do, okay? Now you tell me, if we were multiplying those, what would you do? How would you solve that thing? What would you do?
Simplify the 2 and the 6.
Okay, I had 6 period. They said just multiply straight across. 2 times 1 is 2, 3 times 6 is 18, and then you have to reduce that, right? But if you reduce to begin with, like the 2 and the 6, to become 1 and 3, then you don't have to reduce later. 1 times 1 is 1, 3 times 3 is 9, and then you're done, right?
But that one's so easy.
That one's so easy. Yeah, that's not too bad, okay? Now, adding and subtracting, you said we had to find a common denominator. So my denominators right now are 3 and 6, yeah? What would a common denominator be for 3 and 6? I could just use 6, right? It wouldn't have to go all the way up to 12. I could just use 6. So this, I would have to multiply by 2 to get 6, right? 2 multiplied by 2 will give me 4. So now I take 4 over 6 and I add 1 over 6. What's that? 5 over, is it 6 or 12?
6.
You don't add the bottom numbers together. You leave it. So 5 over 6. Make sense? Okay, but when we have x's and stuff involved, it's a little bit trickier than that. So that's why we do adding, subtracting in section 7-2. Now, I will tell you, 7-1, we take 2 days to do. So today, tomorrow. 7-2, we're going to take 2 days also to do, because it's kind of tricky. So we won't get to 7-3 until like Friday, right? Well, we'll see. We'll see. Friday. Okay, so multiplying and dividing is what we're doing right now. Rational expressions, here's an example of a rational expression. If we think about like the parent, like the very most basic rational expression, his parent function is y equals 1 over x. Do you know what he looks like when we graph him? Do you remember what we called him? 1 over x. What does he look like when he's graphed? Yeah, that's exactly what it is. So this is kind of what we're dealing with. Kind of some weird, tricky stuff like that. Okay, these are boomerangy guys. We'll deal with the graph of him not in this section, but later on. But this is kind of the direction that we're headed in this chapter. Okay, 1 over x. What?
Why are we always doing them?
I don't know. I don't know. Okay. All right. Now, draw your attention to this problem right here. They have solved it for us, but we're going to go through and solve this real quick, and I'll show you kind of how this works. X squared minus 4x plus 3. Okay, here are some illegal things. Ready? Here are some illegal things that you are tempted to do a lot, and I've seen it before. I've seen you guys try to do this. You did this on your test, right?
The next part.
What are you talking about? I just squiggle that out because we're going to solve this thing, okay? Here is what I have seen done before. Don't write this down, but watch. Romeo, watch. X cancels with X. and x squared cancels with x squared, and then you have negative 4 plus 3 is negative 1, and you have negative 6 plus 5 is another negative 1, and negative 1 divided by negative 1 is positive 1, and positive 1 is the answer. That is not correct.
What?
But I've legit seen that done before.
I did.
Okay? Alright, so you did that? That's a thing. That's the thing. So, here's what is illegal. Okay? Pluses and minuses, like, marry things together. Like, things are bonded together with pluses and minuses. Okay? Multiply and divide does not marry things together. We'll talk about that here in a second. But pluses and minuses glue things. Pluses and minuses glue things. Yeah, well, kind of. So this, if we want to reduce things, we have to break them down. Right? This is one whole chunk at the top. So what we can do, though, is he is a simple trinomial. We can break him down into two pieces. Right? So you ask yourself, what can we multiply to get 3, but when I add them, give me negative 4?
No.
What?
No.
-3 and -1.
Negative 3, negative 1. Does it matter which one goes first? No. Okay, this bottom one, he is also a simple trinomial. Multiply to get 5, add to get negative 6.
-1 and -5.
Negative 1 and negative 5. So x minus 1, x minus 5. That will work, okay? Now, looking at these, like this one chunk up at the top here, turned into 2 chunks. We made them into 2 chunks. The bottom one chunk was made into 2 chunks, okay? And now, any of those chunks can get reduced. So, on the top, what reduces with the bottom? X minus 1. That whole thing will cancel off those 2. And all you have left in your answer is x minus 3 over x minus 5. Do you see that? They have it off to the side over here, right? There's that. Okay, now, one more thing that I'm going to add to this that they don't already have. I don't ever want to have 0 in the bottom, all right? I don't ever want to have 0 in the bottom. So what can we not have x be?
5. 0. 3. 5.
5. If I plug 5 in right here, this would end up being 5 minus 5 on the bottom, right? That would end up being 0. I don't want that. Now, x could be 0. Let's take a look at that, right? If I do 0 minus 5 on the bottom, that's negative 5, right? And I can have negative 5 on the bottom, right? I just can't have 0. So if x was 5, then I would be, like, in big trouble, right? So we have to also include the x can't be 5, and then we're good to go. Okay, we reduced him, all that good stuff, and now we're good. All right, let's go to example 1. So part A is this guy, okay? Now, let's pay attention to the chunks and, like, what's glued together and what's not. So how many chunks do we have on the top? 1, 2. This whole thing is a chunk. Now, within that right side chunk, we have 3 terms, right? But that's all glued together, right? He can't get unglued. We can only unglue him if we factor him down, right? So he is a simple trinomial. I'm going to leave the 5x. But this guy, can you multiply to get 3, but when you add them, give me 4?
Yeah.
Positive 3, positive 1. X plus 3, x plus 1. I'm running into whatever.
You foil that?
No, if we foil it, we get back to the original, so we're not going to foil it.
Oh, okay.
Okay, we're just going to cross stuff off if we can, okay? Now, let's go through. We have 2 chunks on the bottom. Do you see the 2 chunks? Okay. X minus 3 is a chunk. Can he be reduced or factored? X minus 3, can you do something with that?
X minus 3.
Can you do something with this x minus 3 on the bottom? Or x minus 6. I'm trying to give you the answer right now, and I can't. X minus 6, can you do anything with that?
X plus 3, but no.
Okay, x minus 6, we can't do anything. What about x squared minus 9?
Yes.
X plus 3 and x minus 2.
That is a... What?
Greatest common factor. No.
DOS. What's DOS stand for? Difference of squares. We're going to break them down as a difference of squares. So, x squared, the square root of x squared is x. So, x goes here, x goes here. The square root of 9 is
Positive negative
3 and 3. One's plus, one's minus. That's how you factor a difference of squares. So, that's one thing that we can use to break them down. All right, so make a list off to the side over here. Breaking down. Breaking down, we have number 1, we could factor him as a simple trinomial. Number 2, we have difference of squares. Okay, these are all factoring methods, breaking stuff down. Simple trinomial, difference of squares. All right, let's go back to our example here. All right, now that we have them broken down, is there anything that we can reduce? X plus 3, x plus 3. Those cancel out, right? Okay, anything else?
No.
What about like this x and this x?
No,
No.
How's come?
because they're in a problem.
They're glued by the pluses and minuses, okay? You can't unglue them. All right, so that top, what's left on the top? 5x and x plus 1. So we're not going to put them back together. We're not going to multiply back together. We just leave him the way that he is now. And right, what's left over, right? X minus 6 is left over and x minus 3 is left over. Okay, now what can x, that's what the next question, under what conditions is the expression undefined? We don't want x to be certain things. I cannot have 0 where?
If x is 0 on the bottom.
I can't have 0 on the
Bottom.
bottom. I don't care about the top, right? Like x could be -1, right? I don't care about x being -1. If I plug into the top, that's fine. But x can't be that stuff on the bottom. Okay, so x can't be +6, right? And x can't be +3. That's those two, right? Okay, now, do you understand where we get the 6 from and where we get the 3 from?
Yes.
Okay?
Yeah.
Yes, right? It's kind of like setting those bottom two equal. Oh, let's say not equal. Cross that off. X can't be 6, x can't be 3. Are you here to get that? Yes. Just grab it. It's down there at the bottom. Oh, what do you have? 220.
Is it $20?
Possibly. Okay, here's what I want you to do. On example 2, do this really quick. This guy breaks down. Figure out what he breaks down to be. This guy breaks down. Figure out what he breaks down to be. Those are trinomials. Figure them out. Write them down. Go. Well, let's just do this. Okay.
You sure?
Yeah.
Thank you.
Last game tonight.
Yeah.
Yeah.
What can I do to get negative 19? What times what? It's 14.
Reese, what
I'm
time do you
done,
have,
so what do I gotta do now?
Hold on. Just wait a second.
Six.
We're gonna get to that.
Is anyone
Okay.
here before or after you?
All right, Isaac Mackin, are you stuck?
Yeah.
Okay. What can you multiply to get 14? But when you add them, give you 5. There's not a whole lot of things you can multiply together to give you 14. I'll tell you that. What can you multiply to get 14?
72.
7 and 2. Okay. I want to add them together to make a -5. So which one of those has to be negative?
2. No, I meant 5. 7.
The 7, right? 7, -7 plus 2 is -5, right? That's how I wanted to break that down, okay?
Okay.
Now, the bottom one. Multiply to get 8, add to get 6. Not a whole lot to multiply to get 8 either. 4 and 2, okay? I want to add them together to make +6.
It'd be just 4 and 2.
+4, +2, right?
Yep.
Okay? All right, now let's cancel stuff. So we have him all broken down. He's ready to go.
You did X plus 2.
X plus 2's cancel out, right? Okay, we've broken him down. Okay, anything else cancel?
No.
No.
No. No.
No.
How many chunks do you have on the top now that we've canceled stuff?
2.
You have this chunk and this chunk, right?
Yeah.
Okay, on the bottom you have this chunk and this chunk,
Don't do us.
Right? okay? This chunk is trapped. So is this one, because they're trapped with the 7 and the 4. But look at these guys, x squared and 4x. If I just said x squared over 4x, could you take an x out?
Yeah.
And reduce them, cross them off? They're not trapped, right? Multiplying,
But this
4
is
and x
squared.
are multiplied, hold
It
on,
just
4 and
be
x
x.
are multiplied together, right? Multiply doesn't bond things. Only adding and subtracting bonds things, okay? Adding and subtracting is the only thing that makes them trapped.
So divide by 4.
Okay, so
No, just take
we want to reduce it by x. Like, what do they both have in common? They both have an x, right? So I'm going to take this x. Remember that x squared just means x times x. That's what x squared is, right? Okay, so if I take one x out of the bottom, I'm going to have one x out of the top, right? Okay, so on the top, all I have left over is the other x and x minus 7. What's on the bottom?
X minus 4. Or x plus 4.
X plus 4 and 4, okay? You can multiply them back together if you want, but we're going to leave them. Then, what can x not be?
Negative 4. Right?
X can't be? Yeah, -4. If you set this guy equal to 0, that's what he can't be, right? What about 7?
7.
Can x be
That doesn't
7?
matter, 'cause 0 can be be on the
Oh,
top.
it doesn't matter.
Yeah.
Right? Okay, so I went ahead and somebody at 6th period didn't understand this. If I try to plug a 7 in, let's plug 7 in.
Oh,
So we have 7 times, what's 7 minus 7?
0.
0 over 4 times what's 7 plus 4?
11.
11. So 7 times 0 is 0. 4 times 11 is 44. What is 0 divided by 44? 0. Can you have 0? Yeah, right? Versus if the roles were reversed and you had 44 over 0, what's that come out to be? Undefined, right? That's when we have a problem. I can have 0 on the top, I can't have 0 on the bottom, right? My calc kids asked me this last period because they were unsure. What is 0 divided by 0? Is that 0 or is that undefined?
1.
It's 1.
Undefined.
It's 1.
It's undefined.
Just 1.
It's undefined.
That was a no.
Because any number divided by 0, any number divided by 0, whether it's 0 itself or any other number, anything divided by 0 is undefined. Always. I have a poster up there, right in the middle. You see the circle with a line through it that says friends, don't let friends divide by 0. Don't divide by 0 in my class. Okay? Friends don't let, right here. Friends don't let friends divide by 0. Don't divide by 0 in my class.
Oh, never noticed it.
There's another one somewhere, I think,
I look at
that
these
talks about
posters all
dividing
the
by
time,
0.
I just don't remember.
I don't know. Maybe I have to get down.
Does that mean you're
Oh, right here. It's behind the TV. You can't see it.
It's all fun and games.
It's
until
all fun and
someone
games
divides
until
by
someone
0.
divides by 0. Can you see that?
Yeah, I can.
Yeah? It's all fun and games until somebody divides by 0. There you go. Don't divide by 0 in my class. All right? So, it's undefined. Doesn't work. I don't know. Okay? I know. We played that this morning, 6th period. You want to hear it? Have you heard it?
What?
And Cookie Monster is sad because he has no cookies, and you are sad because you have no friends.
Oh, is he on the
No?
Siri
You want
thing?
me to play it? Here you go. Ready? I don't either. I don't have Hey Siri, whatever, but I can hit the button, I think.
I don't have her at all.
When you
Hey
say
Siri, what is 0 divided by 0?
Imagine that you have 0 cookies, and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And your friends are sad because they don't exist. Oh wow, this escalated quickly.
It used to be, and you are
You're
sad that
sad.
you have no friends, but somebody was offended somewhere, and so they switched it. Anyway,
How are they
So,
offended by that?
can't divide. I
Still
don't know.
offended.
You can't divide by 0.
Miss Riley doesn't have.
You can't divide by 0. All right, so let's go to example 3. This is one little tricky thing to this example, so pay attention to this one real quick. So, how many groups or how many chunks do we have on the top right now? 2, right? This bubble and this bubble, okay? How many chunks on the bottom? 2. Okay, let's deal with this first chunk. We just go chunk by chunk. That chunk, is there anything I can do with that?
No, I don't think so. Not much.
W?
He's not a difference of squares. He's not a trinomial. What? What did you say?
W.
W. What about the W? What about the W? Greatest common factor. We can pull a W out, right? Can't we?
Yeah.
Anything else we can pull out besides the W?
No.
I don't know. Let's just do a W for now. So if we pull a W out, okay, what's 4W squared? And we take out a W.
4
Just 4W, right? Okay, minus 3Y, yeah? Okay? Now, that was another method. Let's add that to our list over here. Method number 3 is the greatest common factor. We pull stuff out.
You make it negative.
Just wait, we'll get to that. You're exactly right. Yes, if you want to go ahead and do that, you can. But that's what we're doing. Just wait. Just don't. Just wait. She's ahead of us. All right.
See the steps.
You need to slow down.
What? Step number 3, or a third option of breaking down is doing a greatest common factor. That's another thing you can do to break stuff down. Okay? All right. Let's go down here. Let's go to our next bubble. W plus Y. Can we break him down? No, so we just write W plus Y. Okay, on the bottom. This first chunk right here. That chunk on the bottom. 3Y minus 4W. Can I break something down or pull something out or do something? No. So 3Y minus 4W. Okay? What about 5Y plus W?
Teachers, please dismiss the junior high boys basketball players.
Not 5Y plus W. 5W plus Y. Okay? Now, anything cancel?
No.
Can this W plus Y cancel with that 5W plus Y?
No.
No. Okay. This is 4W minus 3Y. Is that
No.
different from 3Y
Yes.
minus 4W?
Yes.
Well, that's not very exciting. Nothing cancels out,
So that's the answer.
right?
That's the answer. Is it undefined?
So Reese says, Can you pull a negative with the W? Let's see what happens when you pull a negative with the W, okay? So if I pull a negative with the W, what happens to this 4W?
Negative.
It turns negative, right? What happens to the 3Y? Positive, okay? Is negative 4W plus 3Y the same thing as 3Y minus 4W?
Yes.
Now it is, right? So those two cancel out. And what's left over?
Negative W.
Negative W times
W plus Y.
W plus Y over
5Y. W plus
5W plus Y. That is what he is, yeah? Yeah, that's very exciting. That's very exciting, okay? All right, and we're going to go through, do you guys have your homework page?
Yeah.
Here's your homework. We're going to do number 1 together, though, and then we're going to go through and label some things. That's all the notes that we're going to get through today because I just want you to practice doing that. So you're going to get a lot of your homework. You're going to get your homework entirely done today, hopefully. 1 through 7 is what I want you to do for homework. Just 1 through 7. If you want to attempt to do some of the other ones, you probably can. But let's go through and let's talk through some of these. Like number 1. Okay?
We only do 1 7?
Number 1. We'll do number 1 together. What?
We do 1 through 7 odd.
What do you mean?
Put the 8x to the third y and put them inside parentheses.
I mean, you can if you want to, if that helps you think about it. But the 8x cubed y, can I cross out the x's and the y's and the 8s and the 12s and all that good stuff? Can I do that? Or are they trapped?
They're all
Yes,
connected.
you can do it. You can do it. There's no plus.
Oh, because they're multiple.
The only thing that glues them together is pluses and minuses. What is the 8 and the x and the y doing to each other? Multiply. Does multiply glue things? No, they can cancel freely. So all I do is look at the numbers, right? 8 and 12. What about the 8 and the 12? What can we do?
4.
Divide by, if we divide both of them by 4, right? 8 divided by 4 is 2. 12 divided by 4 is 3. So that becomes 2/3, right? Okay, now let's look at the x's. I have 3 x's on the top. So like x, x, x. And I have 2 x's on the bottom. And if I cancel those, I have x on the top, right? Okay. What about y's?
5 y's on the bottom.
I have a y on the top and 6 y's on the bottom, so I have 5 y's on the bottom. Anything else I can do?
No,
That's it, right? That's all. Okay, those guys can go freely. They are not trapped. I'm going to label that with an NT, not trapped, okay? Let's go through and figure out which ones are trapped and not trapped. So, number 2, trapped or not trapped?
Not trapped.
Not trapped, you can just reduce, right? Not trapped on number 2. Write that down.
Wait, how do you know if
Okay.
they're trapped or not trapped?
Because if there's no pluses and minuses, he's not trapped together, right? Pluses and minuses, the only things that trap the groups together.
What about number
Okay.
3?
What about number 3? Trapped or not trapped?
Not trapped.
Not trapped. Okay, let's talk through those exponents though. X to the 6th to the 2nd power. What happens to that?
Times 2?
You just
Do you multiply or do you add? Is that 12 or 8?
add exponents, right?
No, and you multiply exponents,
Multiply it.
right?
Okay, so here's the deal. If you can't remember, let's think about the 2 different scenarios. Okay, there's that one versus this one.
That's where you add, and that's where the top one you multiply.
The top one's multiply, so this is 12 and this is 8, right? So this will be x to the 12th over x to the 12th. What is x to the 12th over x to the 12th?
It's 0.
Just x.
1. It's 1.
Is it 1 or is it 0?
1.
Well, it's one.
It's 1.
Okay, let's think about if you have like 12 over 12. Is that 1 or 0?
1.
It's 1.
No.
1,
This
right?
is
Same on the top, same on the bottom?
Wait, can you go up? I'm trying to see that.
Okay, that was really kind of fast.
Yeah, I was gonna say.
Okay, there's number 1 or number 3 is 1. Okay? All right, let's go through the rest of these. Number 4, trapped or not trapped?
Okay, that's
Trapped.
Not trapped.
Not trapped. You just have to like reduce stuff, right? Okay? All right. What about 5? Trapped or not trapped? Trapped. So you have to look for things to pull out, right? Or reduce or factor or whatever. 6, trapped, not trapped? Trapped. Look for things to reduce. We have those 3 strategies. Simple trinomial, difference of squares, greatest common factor. Look for those. Okay? 7, trapped or not trapped? Trapped. Okay? So be careful of the ones that are trapped. Anytime you have pluses and minuses, you look for things to break down. And breaking down strategies are simple trinomial, difference of squares, greatest common factor. Look for those. Okay? All right. Use the rest of the time to work. You've got like 15 minutes. You could get done. Right?
Can I use the bathroom quickly?
Okay, yes. I'm going to go back to number 3. There's that. Okay? I'm gonna cancel the video out and then I will go back to it, Isaac, okay? All right, bye people in the video.